Goal of sequence modeling, already we have seen last videos. Can we eliminate the need for recurrent entirely? It means individual, no? Individual reduced, eliminate, eliminated. That is this one, individual eliminated. Then made in channel like that. Output from y naught cap to yt cap. And then feature vector also. And then from input vector x naught to xt, also channelized, that is parallelized. All are parallelized individually. Y naught, y1, y2 up to yt parallelized. And then continuous stream also is there, only one. Long memory also available. So now we got all the things. This feature vector, output, input. Goal of sequence modeling. Idea 1. Feed everything into dense network. No recurrence, no scalable, no order, no long memory. Idea, identify and attend to what is important. Okay. Feed everything into dense network. Attention is all you need. Intuition behind self-attention, attending to the most important parts of an input. Identify which parts to attend. Similar to a search problem, extract the feature with high attention. Like this way. Intuition behind self-attention, attending to the most important parts of an input. Identify which parts to attend to, which parts we have to attend, which parts. Extract the features with a high attention. A simple example such: how can I learn more about neural networks? Understanding attention with search, deep learning, query, how similar, key to the query, key to. Understanding attention with search, query q, key k to value v. Extract the values based on attention, return the values of highest attention. Learning self-attention with neural networks. Goal: identify and attend to most important features in input. Encode precision information. He dosed the tennis ball to serve x vector, input vector. Data is fed in all at once. Need to encode position information to understand the order. Data is fed in all at once. Need to encode position information to understand the order. Learning self-attention with neural networks. Goal: identify and attend to most important features in input. Encode position information. X. What he told: identify and attend the most important features in input. This is the input. He dosed the tennis ball to serve. Embedding. It is embedding here. Okay. Add position information. Position 1, position 2, position 3. This one he position 6, position 0, sorry, dosed. Position 1, D. Position 2, tennis. P. Position 3, ball. Position 4, 2. Position 5, serve. P6. Then sent position aware encoding. Position aware encoding. Encode position information. This one do here. Data is fed in all at once. Okay, once. Need to encode position information to understand the order. Understand the order. Need to encode position. Encode position. This one. Understand the order. Okay. Then learning self-attention with the neural networks. Learning self-attention with the neural networks. Goal: identify and attend to most important features in input. Goal: identify and attend to most important features in input. Encode position information, finish. Extract query key value. This one we are doing now. Query extract, here extract, then key extract, value extract from here. Position our encoding. Okay. Position encoding, linear layer, then output. Total query, key query. Okay. Then positional embedding, linear layer, then output, key output. Then position embedding, linear layer, then output value. Learning, then we got extra query key value search. Learning self-attention with the neural networks. Learning self-attention with the neural networks. Self-attention, learning self-attention by using neural networks. Goal: identify and attend to most important features in input. First point finish. Second point finish. Now compute attention weighting. Okay. Attention score. Compute pairwise. Similarly between each query and the key. How to compute similarly between two sets of features. How to compute similarly between two sets of features. Q, K, key for what here mentioned. Query, K for key, V for value. So here query key dot product. Okay, dot product. So scaling, similarly metric, also known as the cosine similarity. Learning self-attention with the neural networks, identify and attend to most important features input, push information finish, extract query key value for search finish, compute attention weighting. So attention score, compute pairwise, similarity between each query and the key. How to compute similarity between two sets of feature. This one feature one, these two. Query key. So query this one. K key dot product scaling. Okay. Similarity metric, also known as the cosine similarity. Here also similar cosine similarity. It's also similar. Same. Identify data to most button features. Position information encode position information finish. Query extract query key value finish. Compute attention waiting doing attention waiting, where to attend to do, how similar is the key to the query. He dosed the Dennis ball to serve. He dosed the Dennis ball to serve. He dosed the Dennis ball to serve. Softmax scaling Q dot K for T, attention waiting. Learning self-attention with the neural networks. Identify and attend to most important features in input. Last step, self-attend to extract features. Yeah. Push information finished. Encode push information finished. Extract query finished. Key finished. Value of search finished. Compute attention waiting finished. Extract features with a high attention. Extract features with a high attention. Self-attended to extract features. Last step. So attention waiting, value, output. So this one value, this one output, this one attention waiting, softmax, this color, red, value, this color. Okay, this one here. Q dot K power T divided scaling dot value. Okay, and output A of Q comma K comma V. Learning self-attention with the neural networks. Identify and attend to most important features in input. Identify and attend to most important features in input. Encode position information finish. Extract query okay. Key finish. Value for search finish. Compute attention waiting finish. Extract feature with the high attention. This operation form a self-attention head. Self-attention head that can plug into a larger network. Each head attends to a different part of input. Let's see here. Mathmal, positional encoding, linear, value, query, key, value, query going, Mathmal function, scaling, softmax, matrix multiplication, key, query, key, all are here, value only, linear, going here, position encoding. So Q, this query, softmax, up to softmax, KT, all are linear only, KT, yes, dot product, value, scaling. Okay, this operation self-attention get can plug into larger network plug in. Each head attends different part of input. This one, each head, query, key, value attends to a different part of input. These are input, no? These are input. Push input. Applying multiple self-attention heads. Attention waiting, attention value, output. Applying multiple attention head. Attention waiting, value need, then output. Output of attention get 1, output of attention get 2, output of attention get 3. This one output 1, 2, 2, 3. Output attention. Self-attention applied. For language processing, an armchair in the shape of avogada. With this pattern. Then biological sequence, AlphaFold, 2020 paper. Computer vision in 2020 paper. Vision transformers. Deep learning for sequence modeling summary. Run RANs are